All right, today we are going to do our notes for 6.4, predicting products. And this set of notes is going to require two review concepts. The first is about ionic formulas, and the second one is about types of reactions, which you should have just taken notes on. So let's start with ionic compounds. This goes back to chemistry A or first semester chemistry. So we're going to review that idea. So finding ionic formulas. All right, so finding ionic formulas. So compounds are usually neutral. If they're not neutral, then it will tell you that with a charge. So this means that all of your positives and your negatives need to cancel out when you make a formula. So this means the positive and negative need to cancel out. So if I had a question like, what is the formula for, I'm going to use two different colors here just to help me keep track of things. What is the formula if I put magnesium and chlorine together? So first, you have to know their charges, and this goes back to patterns on the periodic table. So I have right here a handy dandy labeled and colored periodic table from the last time I taught the periodic table unit. So go back to your chemistry A, whether you took it in person or virtually or asynchronously, and find your labeled periodic table. If you don't have a labeled one, then you can just memorize the pattern, which is that the column that the element is in, not including our transition metals. So the column will tell you the charge. So the charges go +1, +2, +3, and then this column 4, it can be either plus or -4. A lot of times these elements will either have a special charge or they will be part of a covalent molecule, so we don't have to worry about them as much. Then we go backwards. -3, -2, -1, and 0. These are our noble gases. They have a full set of valence electrons, so they don't usually form a charge. So in my problem, I have a magnesium, so Mg. So I see Mg here, it's in column number 2, it's got a +2 charge. And then I have to find chlorine. Chlorine is in column 7A, it's got a -1 charge. Okay, beautiful, lovely. Now we need to figure out how we could get their charges to cancel. So there's 2 positives and 1 negative, which means I'm going to need 2 chlorines so that I can have 2 negatives. So if I had just regular old Mg, and then I need Cl, but I need 2 of them to get my 2 negatives to cancel out the 2 positives that Mg has. So I need 2 -1s to valence. So then this makes it neutral. If you can't think through that way, kind of logic your way, there is actually a method to do this. It's called the crisscross or swap and drop method. So I like the term swap and drop, but either one works. So crisscross or swap and drop. Depends on kind of how you think about it, but they actually, the name is the instructions. So the first thing you're going to do is find the charges. Okay, so for our example, let's do one that is different from the one that I just did. So let's do Na and NaS. Okay, so Na is sodium, and I see Na here, sodium, it's in the +1 column, so it has a +1 charge. Chlorine is in the -1 column. Oh, nope, we're looking at sulfur. Sulfur is in the -2 column, so -2. All right, we found the charge. Now, my step 2 is that I'm going to drop the plus/minus, so I'm not going to worry about the plus/minus, and bring the number to the opposite element as a subscript. Okay, so I have my Na. And this time I'm just going to put a 1 there, not worry about plus and minus. And then I have my S. I have a 2. And I'm going to crisscross the charges or swap them and drop them down. So I'm going to bring my 2 down here, my 1 down here. And then we are actually ready to write the final formula. And the final formula has kind of 2 rules with it. You reduce, if possible. So like if this was a 2 and this was a 4, then I could do 1 and 2. And we're also going to not write the 1s. So don't write 1 as a subscript. So I have my Na, and I brought the 2 down from the sulfur. And then I have my sulfur, and it had a 1, but I'm not going to write the 1 in my final formula. So I end up with Na2S. And that would be my final formula. This is a method that we use to come up with our ionic formulas. And so let's do 2 really quick practices. So I would like you to find the formulas for boron and chlorine, if they made an element or a molecule, and then beryllium and nitrogen. So pause the video, find those quickly, and then come back to the video and we will go over the answers and move on. Okay, so boron is B and chlorine is Cl. So boron is right here, it's in the +3 column. Chlorine is here in the -1. So then I can put them without their charges. I'm going to bring those numbers down to the opposite sides. Oop, you can't see that. So I end up with B, I'm not going to write the 1, Cl3. I like to do these with colors just so you can see where things came from originally. And then I have over here beryllium, which is Be. Beryllium is right at the top of column 2. So Be +2, and nitrogen is at the top of column 5A, which is a -3 charge right here, nitrogen. So I'm going to drop those charges, and I should do that first. Be2 and 3, and I'm going to bring them down to the other side. And I end up with Be3. Nope, I want to stay with pink. And no formula. All right, that was a fair amount of notes. If you want to take a break before we move on to predicting products, feel free to do so. I'm just going to keep going, and then whenever you're ready, you can move on with me. Okay, so our next thing is that we are going to predict products when you're only given the reactants. So predicting products when only given the reactants. Okay, so the first thing you are going to do is you are going to use the reactants to classify your reaction. That's your first step. Use reactants to classify the reaction. All right, so what do I mean classify the reaction? Well, you got to go back one page in your notebook. So I am going to flip back and I am looking at these. So I could essentially be saying, like, if I was given A plus B, I know this is going to be synthesis. If I was given an A-B situation, I know this is going to be decomposition. So you're just using the left side, the reactants, to figure out what type of reaction you're dealing with. Okay. Once you've classified your reaction, you are going to you're going to determine the products. So if it's decomposition, then you're just going to separate the two elements and balance the equation. If it's combustion, you know your products are always carbon dioxide and water, and then you balance the equation. But if you're making a new compound, a new product that didn't exist, then you have to go through the swap and drop method. So if a new compound is made, then you use the swap and drop or crisscross method that we just went over to find the product. And there's one tricky thing that you also have to keep in mind from first semester, which is to remember diatomics. Diatomics are the 7 elements that exist always in a pair when they're alone. So it's H2, N2, O2, F2, Cl2, Br2, and iodine, I2. I'm going to show you the trick that I use. So there are 7 diatomic elements. So if you, on the periodic table, if you look at element number 7, that's nitrogen, and you make a number 7, so like this. See how that's kind of like a blocky 7? Those are 6 of your diatomic elements, and then you just have to remember that the last one is hydrogen. It's all by itself. Okay, so we've gone over step 1, which is to use reactants to classify the reaction. Then you determine the products using our swap and drop method. And then the last thing that you'll have to do sometimes is, or all the time, is balance the equation. Okay, so this whole process requires a bunch of previously learned skills. So if you are getting to this and you're like, ooh, I don't really think I can predict products, I don't really think I can classify reactions, I'm not very good at balancing equations, this would be a great time in this unit to go to your instructor's office hours and make sure that you understand the fundamental concepts that you've covered so far. Because now we're going to do some examples. I think we're going to do 4. Yep, I'm going to do 1 completely for you, and then we'll kind of go through them a little bit broken down. All right, so my very first example is KOH plus MgBr2. That's all I'm given, and my problem would be something like predict the products and balance the reaction. So I've got to figure out what the heck is going on here. And I see 2 compounds, neither one of which are a hydrocarbon and oxygen. Both of my compounds have multiple elements, so I believe I'm dealing with a double replacement situation. So I'm going to flip back. Look at that, double replacement. Okay, this looks very similar, so I think this is double replacement. The 2 replacement reactions tend to be the hardest ones. That's why I'm starting out with one of these as an example. So what I have to do is I have my A, B, my C, D. And the trick to this in double replacements is to connect the outside ones. So my A and my D, so in this case, K, B, R. And then I have 3 elements here. So what the heck is going on? If I look at my polyatomic ion list, so on the back of your periodic table or on the home page of Schoology, there are a whole bunch of polyatomic ions, and I see OH is one of them. So technically, you could put parentheses around this. There's just none because there's no subscript. All right, so then I'm going to put my B with my C. And when you make these combinations of your new compounds, you always put the positive ion first. Okay, so I'm trying to pair up K and Br. So I have K and I have Br. And then over here I have I have OH and Mg, and we just saw on the polyatomic ion list that OH is negative. So Mg goes first. And then OH. And I'm going to find all of their charges. All right, so K. K is +1. Br is -1. Mg is +2. OH is on the back of my periodic table. That's a -1. You can always just put a minus if it's just a 1. But I like to do the ones because it helps me keep track of things. And then I'm going to crisscross their exponents down to be subscripts. So I'm going to bring the 1s down here. And we don't write 1s, so my K, Br, that's my formula. And then my Mg, when I cross that 1 down here, I don't write it, but I do have this OH, and it is going to get the 2 from up here. So now I've figured out my products, and it doesn't matter if I put KBr first or MgOH2, it doesn't really matter. So I have to actually plug these into the equation and balance, so I could just write them here. I'm just going to rewrite it for simplicity's sake because there's a lot going on. So let's see, let's do KOH plus, this is my original equation, the original reactants, KBr2 yields. Now I'm going to put my new products. KBr plus MgOH2. Okay, I'm so close to being done. I have classified this as a double replacement. I have swapped and dropped and predicted my products, and now I need to balance it. So I have K, I have OH, which I'm going to keep together because that's one of my tricks to make it a little shorter. I have Mg, and I have Br. Lovely, amazing, great. Okay, so on the left, I have 1K. On the right, I have 1K. On the left, I have 1 OH. On the right, I have 2 OHs. On the left, I have 1 Mg. On the right, I have 1 Mg, because remember that 2 only applies to the parentheses. And on the left, I have 2 BRs, and on the right, I have 1 BR. So I could start with the OH, or I could start with the BR. It doesn't really matter. Let's start with the OH just because it's first on my list. So I have 2 over here on this side, so I need 2 over here. So I'm going to put a 2 out front. So that gives me 2 Ks and 2 OHs. Great, I balanced my OH, but now I threw my K out of whack, so I'm going to put a 2 here. That 2 gives me 2 Ks and 2 BRs, and now I have 2 and 2. 2 and 2, 1 and 1, 2 and 2. I am done. I did it. This is my final balanced reaction where I correctly predicted the products. It's a lot of work. Double replacement is a lot of work. Single replacement is a lot of work. So let's actually try actually 3 on your own, but we'll do them 1 at a time. So next up, I would like you to try Li plus Br2. And notice this is that little 2. It's all by itself, but it has a 2 because it's one of my diatomics. Give this one a try. Pause the video. When you're ready, come back and I will explain. Okay, so in my LIBR, I have 2 single elements. I know it's a diatomic, but that still counts as a single. So this is synthesis. This is my A plus B. So it's got to go to AB. So I need to figure out what that AB is. So I have to combine it and get my product. So I've got my Li, which is +1. My Br, which we just did up here, is -1. And just like KBr, I'm going to end up with Li Br as my final product. So I'm going to put that up here. All right. And now I need to balance. So I have Li, I have Br. The nice thing about synthesis and decomposition is that you're just usually dealing with less elements and polyatomic ions, which makes it a little bit easier. So I have 1 Li on the left, 1 on the right, 2 Brs on the left, and 1 on the right. So I've got to start with Br. So I'm going to put a 2 out front here, which also makes Li 2, which is no problem because I can put a 2 here. And now I am balanced. Okay, next up we have, let's get a little bit more complicated. Let's do Mg plus LiCl. So classify the reaction, predict the products, and then balance the equation. And when you're ready, come on back and check your work with my walkthrough. Okay, so I see a single element and then a compound. So this is single replacement. Single replacement sometimes is the trickiest because you have to figure out which element is replacing which one, and it's based on charge. So magnesium we've already figured out today is +2. Lithium is +1. And chlorine is -1. Whenever we make a compound, we need it to have a plus and a minus so they can balance each other out. So I'm not going to put lithium and chlorine together because there's no way to balance those. They're both blue in this case, which represents positive. So if I put them together, the charge would be +3. I can't make it neutral. So that means I have to put Mg with Cl. So I'm going to take my Mg, which we said is +2, my Cl, which is -1, and cross their charges to get MgCl2. All right, and then my other poor lone element is Li. Can't forget about that. So my Mg has replaced my Li. So I have MgCl2 plus Li. Okay, so now I'm going to do my balancing. MgCl and Li. Okay, so first count, I have 1 Mg on the left, 1 on the right. I have 1 Li on the left. Nope, that's Cl. 1 Cl on the left and 2 Cl on the right. And I have 1 Li on the left and 1 Li on the right. So my chlorine is out of balance. So I have 2 here. I'm going to put a 2 out front here. That makes this a 2 and this a 2. So I need a 2 here to finish that out. Okay. Our very final problem for this long set of notes today is here. All right, try CuCO3 plus N2. Classify, predict your products, and balance. Then come back and check your work. Okay, on this one I gave you a freebie because I put parentheses around the CO3 on accident. They shouldn't actually be there because it's a 1. That's okay. So I'm just going to write my charges up here to figure out what's going on. So copper is part of our transition metals. It's right here. So I'm going to, I guess I would have had to give you that charge. So if you couldn't figure out how to do this, you had to come back. Copper is +2, but there is a way to figure that out when it's not given to you in the problem. So I have CO3. CO3 is right here. It has a -2 charge. And we know that compounds are always neutral. So if CO3 is -2, then copper has to be +2. So if you couldn't figure that out, that's okay. That is the trick to doing so. And then nitrogen is -3. So this time I need my negatives to swap out. So I'm going to end up with Cu +2 and -3, and they're going to swap across to get Cu3N2. And then did I just do that wrong? No, that's right. Okay, and then I also am going to have my CO3s. Okay, so now I need to balance things out. So I'm going to hop in here and do my counts. So I have Cu, CO3, and N. Oh, and I forgot to write. We said this out loud, but this is a single replacement. All right, so my Cu, I have 1 on the left and 3 on the right. My CO3, I have 1 on the left and 1 on the right. And my N, I have 2 on the left and 2 on All right. So I'm going to start with my CUs. So over here I have a CU, and on the right side I have 3, so I'm going to cross this out. I'm going to put a 3 out front and then make this a 3. That also changes my CO3. That makes it become a 3. So then I need to put a 3 here, and I'm all set and done. That was a long set of notes. Like I said earlier in these notes, this is a great point in the unit where if you are confused, it's time to go to office hours and check in with your teacher. This is a much more complicated unit than the previous one, and it's longer. So your teacher, your instructor is there to help. That's what office hours are for. So if you're trying things, just pop into the Zoom, ask some questions, maybe do some of the worksheet problems together, and that should help you understand things at a better level so you're ready to take your assessments and you've learned all the material you need to learn. Take a picture of these notes, make sure that you turn them in on Schoology, and then do the practice.